Okay, today we're picking up in our notes with types of chemical reactions. So now we've talked about balancing chemical reactions, and then today we're going to be able to identify the types of chemical reactions. So we start with a few pictures here. We have a precipitate being formed. We have a combustion reaction, all right, when we see fire or heat. We also have a decomposition reaction. So there's just some pictures to get you thinking, but the title is Types of Chemical Reactions. First type is called synthesis. Now the word synthesis means to create. Okay, sometimes this is also called combination, but we're going to call it synthesis. So in a synthesis reaction, two or more substances come together to make a single substance. All right, so I'm going to give you an example formula here. So let's say we have compound A, or element A reacts with element B. It's going to yield compound AB. So in a synthesis reaction, two things become one thing. And here's some examples that are actually chemical equations. So we have potassium reacting with chlorine to make a compound. So single things, single elements, combining to make a compound. A plus B gives us AB. Okay. Next type, decomposition reaction. So when you think of decomposition, you probably think of decay, breaking down, and that's perfect. So our definition for a decomposition reaction is a single compound is broken down into two or more products. So one thing breaking down into two things. It's exactly the opposite of a synthesis reaction. So for our formula here, it's going to be, it's going to be the exact opposite. So let's say we started with compound AB. And we broke it down, we decomposed it into A plus B. Okay, so it's exactly the opposite of a synthesis reaction. Here's a couple examples. We have calcium carbonate breaking down into calcium oxide and CO2. So it doesn't necessarily have to be single elements, but one thing on the reactant side, multiple things on the product side. And this picture is just of a compound being decomposed using heat. Next thing is a single replacement reaction. And here's our definition. One element replaces another in a compound. So I'm going to go ahead and write our AB format for this. If we have compound A and it's reacting with element A reacting with compound BC, in this, A is going to take the place of B in the compound. So then on the product side, we're going to have compound AC, and now B is by itself. Okay, so something by itself kicks out one of the elements from the compound. All right, so that's a single replacement reaction. So here's a couple examples. We have magnesium reacting with zinc nitrate, and then magnesium, you can see magnesium kicks zinc out of the compound. The next type is called a double replacement reaction. On our definition here, it involves an exchange of positive ions between two reacting compounds. Generally, it takes place between ionic compounds to form a precipitate. Remember, that's this insoluble solid that will form. And let me just see here. I'm going to write our I don't know if I wrote. Here's the example. We have sodium sulfide. You notice sodium is going to exchange places with cadmium. They exchange partners. They're the positive ions in those compounds. So now we have cadmium sulfide and sodium nitrate. And it turns out that cadmium sulfide ends up being a solid when it's formed. For our AB format, let me just move my screen over so I have some space to write. So for this one, we'd have, let's say, compound AB plus compound CD yields A bonded with D and C bonded with B. Notice A and C exchanged partners. Oops, I don't think I did that right. All right, so that's single and double replacement, one type, and that's a picture of a precipitate here. One last one is combustion reaction. So when you think combustion, hopefully you think fire, flame, and that's exactly what it is. So the technical definition is an element or compound reacts with oxygen to produce energy and light. Usually involves hydrocarbons. So what's a hydrocarbon? It's something made of hydrogen and carbons. So which produces CO2 and water. So this here, S plus O2 gives us SO2 is an example of a combustion reaction because it reacts with oxygen, O2. Same thing here, CH4 is a hydrocarbon reacting with O2 to give us CO2 and water. Okay, so as long as it has O2 in its reactant side, it's going to be combustion. So there's no AB format for that one. And you can take a look here. This is what's happening in our Bunsen burners. We have fuel coming out, that's the methane, and then it's reacting with the air to produce CO2 and water. Okay, so those are the 5 types of reactions. We're going to look at some examples. All right, so what I'd like you to do is you're going to go along with me and we're going to say whether these are, what type of reactions these are. And we probably won't need to go through all of these, but let's take a look. We have P4 plus O2 gives us P4O10. If we notice, this is 2 types. We have 2 things becoming one thing, so this is a synthesis reaction, or it can also be a combustion reaction because we have O2 here. Okay, so when I'm asking the types, you just need to write the first letter. So S is for synthesis and C is for combustion. Here we have zinc and HCl reacting. Notice zinc takes the place of hydrogen in the compound, and then hydrogen's left by itself. So this is single replacement. So I'm going to put SR for single replacement. Zinc took the place of hydrogen. Number 3 here, we have magnesium reacting with oxygen to give us MgO. 2 things becoming one thing, so it's synthesis. Also, magnesium is reacting with oxygen, so you could also say it is combustion. Next one, we have one thing, KClO3, reacting with KCl and O2, so one thing becoming multiple things. This is decomposition. Don't be confused, it is not combustion because it doesn't react with O2, it produces it. And let's take a look at this one. So again, this one would be, what do you think? Combustion. We are reacting with oxygen. All right, so this is only combustion because we're not getting 2 things becoming one thing. There are multiple things here. All right, let's do another set quick for review. And these will be the last ones we do here. So here we have CaCO3, so calcium carbonate, one thing becoming multiple things. So this is decomposition. Here we have calcium bromide and sodium phosphate. If you notice, calcium and sodium switch places. So now calcium's with phosphide and sodium's with bromide. So this is a double replacement. Here we got copper and silver nitrate. You notice copper takes the place of silver in the compound, and now silver's by itself. So it is a single replacement. Last one for today, we have aluminum reacting with oxygen to give us aluminum oxide. So 2 things becoming one thing, it's synthesis, or because oxygen is reacting with aluminum, it is combustion. All right, so let me know if you have questions, and that's it.